Hello, welcome to the trig unit. So meet me on page 4 of your notes packet, and let's talk about where we've been and where we're headed. So we know how to find the missing angles or side lengths in a right triangle. We could either use Pythagorean theorem, or we could use the fact that we know that all these angles are supposed to add up to 180. Or we could use SOHCAHTOA. Okay, so these are all the methods available to us to solve for missing angles or sides in right triangles. Now let's make this IB and talk about how we would find missing sides or angles in non-right triangles. These are called oblique triangles. An oblique triangle is a non-right triangle. Okay, and for example, one can maybe look like this, okay? It's really important that when you're working with oblique triangles that you label your sides according to the angle that they are across from. So let's say we label this angle A. You always want to make the angles capital. The side across from him would be lowercase a. Let's say this is angle B, the side across from him would be lowercase b. Let's say this is angle C, the side across from him would be lowercase c. So angles are angels because they guide us to see what corresponding side they are across from. When you're working with law of sines or law of cosines, it's really important that you mock up your figure right away because that's what's going to help you find all your unknowns. So there are two different things that we can use to figure out unknown side lengths in oblique triangles. First, we have the law of sines. And the law of sines states that the sine of capital A, so we're talking about angle A right here, over side length A is proportional to the sine of B, angle B, over, the side B, okay? When is this useful for us? This is useful for us when we have two angles and one side that are known, or two sides and a non-included angle. What do I mean by included or non-included? So let's say I have a triangle that looks like this, right? A, B, C, and we know this angle, he's going to be considered an included angle because he's between two known sides, whereas if I have side length A is 4, side length B is 5, this would be considered a non-included angle because it's not included between the two sides. So we can use the law of sines or we can use the law of cosines. Notice how the information given to us is going to dictate the method that we select. In the law of cosines, we have c squared is equal to a squared plus b squared minus 2ab cosine of c, okay? Alternatively, you could solve for different variables if you would like. You could see it like this. B squared is equal to a squared plus c squared minus 2ac cosine of b. Or let's say you have a squared is equal to b squared plus c squared minus 2bc cosine of a. Okay, so these are all going to depend upon the side lengths and angles that you do have and the sides across from them that you may or may not have. Okay, that's going to be the version that you select. This is the general one. This is the general one. Okay, so you would use the law of cosines when, like, think about the criteria for using law of sines, two angles and one side unknown, or two sides and a non-included angle. So you would use law of cosines for all other cases. And when you have all three sides and you need an angle. Okay, so let's see how this would look if we are looking for that special case here where you need an angle, right? That's going to look like this. You have the cosine of A. They just solved for a different piece of this. Like here in this version, they just solved for this piece here. Okay, so that's where this formula comes from. So we have the cosine of A is equal to B squared plus C squared minus A squared all over 2BC. Or alternatively, like this is like the general one, and then alternatively, you could see it as cosine of B is equal to A squared plus C squared minus B squared. You could start making like generalizations in your head now, right? If I'm looking for angle B, then A and C are going to be the two pieces on the bottom, and I'm going to be subtracting off the B squared. And then if you're looking for angle C, you would have A squared plus B squared. You're subtracting off the C squared, and then down below you should have 2A and B. Okay, so you don't need to memorize these, but you can use them if you want. Okay, so let's do some practice problems with law of sines and law of cosines. All right, let's go to, I think a really nice version is question number 9. Let's go to question number 9. This unit gets tricky because you have to be able to determine the difference between when you have your calculator in degree mode and when you have your calculator in radian mode. And I always just go off of the figure that they give me. So in the figure that they give me, they have 120 degrees. So right away, before I even start the problem, I'm going to make sure that I am in the proper mode. You go to your calculator and you can just hit this and it will change from degree to radian. So right now it says DEG. I'm in degree mode. Perfect. I'm ready to do this problem. So it says the following diagram shows triangle ABC. So I'm going to label my figure accordingly. So across from angle B, I have side B. Across from angle A, I have side A. And then across from angle C, I have side C. I'm going to erase these before the picture gets crazy. Okay. So now it says AB is 7, BC is 9, and angle ABC is 120 degrees. Find AC. I am looking for this side length here, AC. AC. Okay. So I have, let's see. I have two sides, and then I have an included angle. So that means I'm going to be looking for this side length here, AC. Ooh, law of cosine sets me up perfectly because check it out. The unknown side length is right across from that angle. So I can just use law of cosine, set it right up. And here we go. So I'm going to write down B squared is equal to the other two minus 2, the other 2, and then the angle across from the side that I'm looking for. So this is AC, he's squared, and that is going to be equal to A, which is 9 squared plus 7 squared minus 2 times 9 times 7. Cosine of B is 120. So I just typed this into my calculator, right? And I get 193. I have to take the square root of that, though. And then I'll get my side length, okay? So I have AC squared was equal to 193. I took the square root of both sides, and I got AC is equal to 13 point, and then I'm going to round that to 3 sig figs, okay? Centimeters. All right, so now B says find angle BAC. So angle BAC is going to look like this. BAC, so I'm looking for this angle right here. I know 9 is across from this guy, and then I also know this angle, and now I know the side that's across from that one as well, so I'm going to use law of sines. So I have the sine of 120 goes with 13.9. Let's use the unrounded version, though, because I want this to be as exact as possible. It's still up in my calculator, so I'm just going to copy it off my calculator, 38924. Okay. And then sine of BAC goes to the side length of 9. So now I would just have the sine of 120 times 9 divided by this guy. And I have the sine of BAC is equal to 0.561041. So the way that we solve for an unknown angle is we use the function inverse sine. And when I inverse sine sine, I end up with whatever the angle should be in there. So this would be inverse sine. So now I would do the inverse sine of this piece right here, and that will give me an angle measure of 34.1 degrees. Notice how in IB they don't use the angled piece out front that looks like this, like you used to in geometry. They do it where the vertex goes in the center. Okay, cool. So that was our example that uses both law of sines and law of cosines. So now we are going to talk about, let's do a version in radians. Sorry, I'm probably making you nauseous scrolling this thing so much. Okay, so go to question number 7. And let's talk about doing this in radians, okay? So in question number 7, it says the following diagram shows a quadrilateral ABCD. Before I even start anything on the problem, I see that these are decimals. And if I added them all up together, I want them to be equal to pi, which is 3.14. So when these are really tiny decimals like this, I know that I'm going to have to be in radians. So let me just change to radians. And here we go. I'm just going to start with a new document because I don't like all this stuff on here. Radians. Okay. Now it's back in degrees. There we go. So really be very militant about knowing when to use the right mode. Okay. So we have the quadrilateral, ABCD. Okay. AD is 7. BC is 8. I'm just checking where all this stuff is located on the document. Okay, CD is 12, angle DAB, so DAB is 1.75, ABD is 0.82. Okay, find BD, so I'm looking for this side length here. So this side length, I have known angle across from a side, and then I have known angle across from the side I'm looking for. I'm going to use law of sines. So I have the sine of 0.82 is across from 7, and that is proportional to the sine of 1.75, which is across from BD, the length that I am looking for. So I'm going to do that on my calculator. I have 7 times the sine of 1.75 divided by the sine of 0.82. And that is going to give me 9.42. So I have BD is equal to 9.42. I'm going to put that on the figure in case I need to use it later. Okay. Then it says find DBC. DBC looks like this. Okay. So DBC, that is an unknown side length. And, I have all 3 sides. I mean, that is an unknown angle, and I have all 3 sides, so that means I'm going to use law of cosines. So for law of cosines, I'm going to use the cosine of C is equal to A squared plus B squared minus C squared, and then 2AB. These are all in your formula booklet, by the way, but you should definitely memorize them because you know that our tests are timed, and we need to know this stuff like the back of our hand. Okay, so let's label this stuff, right? This is C. DBC. So this is the angle that I'm looking for. So he's got to be C. So across from him has to be C. And then these will be the other 2. So this one will be, let's call him A. Let's call him B. Okay. So I've got the cosine of C. That's my unknown angle. And then A squared is going to be 8. And then B squared is going to be 9.42. Okay, so I've got 8 squared plus 9.42 squared minus 12 squared. That was the other one. And then this is all over 2 times 8 times 9.42. So I just typed this in my calculator. And I'm just just going to pick up the piece from up there because I want it to be as exact as possible, squared. Oh, whoops. Oh no, what happened here? All right, sometimes I guess picking it up, it gets mad. So I will just write it in then, 942,069. Okay, and then down here. Okay, and I have 0.058046. Okay, so that's the cosine of C. That's not C, that's the cosine of C. So I've got to do inverse cosine to figure out what the angle measure is. All right, so inverse cosine, both sides. Inverse cosine, both sides. And I get 1.51 radians. So C, or let's call him DBC. Let's answer the question the way it was asked. DBC is equal to 1.51. And then you can either write radians or you can leave it off. It's fine. Radians don't need their units right now. Okay. I'm actually going to break this video up. I think I'm going to do the angle of elevation and bearings in a part 2. Okay.